Hi everyone, we're going to start our notes today with a translation. So if you open up your packets to the section on translations, I believe it starts on page 22. We're going to pick up right here and talk about what exactly is a translation. So a translation is nothing more than a slide of an object some fixed distance in some direction. So translations always need to tell you like which way they're moving and how far they're moving. When you're done with a translation, you're going to end up with an object that's the same shape, and it's the same size, and they're going to face in the same direction. So that tells us it's going to be a direct isometry from what we did before. To save us some time in our notes, I'm going to skip through the reading here. But if you look through these, they give you different examples of translations you can find. We'll look down at the next section that says, in math, the translation of an object is called the image. The image is where we end up after we do our transformation. The pre-image would be our original object. And if we labeled it with the letters A, B, C, D, E, like this pentagon we have here, that means then that the new one, the image, would be called A prime, B prime, C prime. We use the same prime symbols that we did before. Think of the polygon A, B, C, D, E as sliding 2 inches to the right and 1 inch down. So I tried to show that if you started here at point C, you'd go 2 inches to the right and 1 inch down. There's my new point C. We call that C prime. Same thing happens to B prime, A to A prime, E to E prime, and so on. And we're going to see that the translation is nothing more than moving the object. Now, an interesting question here is if you look at the picture, if I asked you about the path from C to C prime and E to E prime, what do you notice about those? Now, you can simply say they both went right 2 and down 1, but if we wanted to go directly from C to C prime, you can see that that's the movement I'm really doing there. If I was to look from E to E prime, if I was to draw that a little bit better, what could you say about those two arrows, those two rays that I just drew? They should both be parallel to each other. And if I had endpoints on them, they'd both be congruent in length as well. So when we move an object, there's going to be direction, but the final ray that you want to call it, if you want to get into vectors soon, we'll see that the vectors are going to be congruent to each other. The actual notes we want to talk about, here are the rules that you can use with a translation. Unlike reflections where things are usually just changing the sign or maybe the order of something, with a translation, we just want to do some addition or subtractions of the point. Now we can think of everything as addition. If it's positive, we just add the number on. If it's negative, we add the negative. But that's easier sometimes to think of as subtraction. And there's different ways you might see this. So if we're going to look at different types of symbols, you can see a translation with symbols like that with a capital T. The capital T is a symbol for translation, and they'll give you 2 numbers underneath it. Or you might see it written more like an ordered pair, where you have a number plus a number, comma, number plus a number. That gives you the directions to where you're going as well. And we're really looking at this in the X direction and Y direction. So the first value represents the X value. The second one is the Y. So positive X means right, negative X means left, positive Y means up, negative Y means down. So it really tells us how far we're moving. So for example, if I give you the point R, which has the coordinates 6, negative 7 to start with, and I want you to translate it with the rule of capital T 2, 3, that just tells me I want to move right 2, up 3. Well, right 2 means I'm going to add 2 to the 6. So 6 plus 2 is 8. I start at negative 7 with the Y and I go up 3. So negative 7 plus 3 is negative 4. If you try it with negative 3, 1 under the translation of 2, negative 6, that tells me to start at point D, move right 2, down 6. Right 2 tells me to add 2 to negative 3. So negative 3 plus 2 is negative 1. And the negative 6 tells me down 6. So 1 minus 6 is negative 5. D prime would be negative 1, negative 5. Number 2 is the same thing. It's just a different way to write it. So instead of doing a translation with a capital T and 2 numbers, you might see a capital T here in front of this. And then when you have the capital T here, they might put some numbers underneath it in parentheses, maybe not in parentheses. Sometimes you use vector notation instead, which would be more of a pointy bracket on the end. And that's just telling you how far to move it as well. A lot of ways to do the same thing. This is going to tell me to subtract 3 from the X value. add 2 to the y value. So 7 minus 3 is 4. Negative 8 plus 2 is negative 6. If I try it with point B starting at 6, negative 6, I add 3 to the first number. I subtract 1 from the second number. So 6 plus 3 is 9. And negative 6 minus 1 is negative 7. So to summarize all that, just notice that when you do a translation, you're just sliding it, shifting it, moving it over. All the points on the original shape are going to travel the same direction, the same distance. So each movement is going to be parallel, and it gives us a direct isometry where the object ends up exactly the same orientation and the same size as the original. So a couple questions to practice together before you try your homework tonight. We're going to look at the next page where it says in class. There's going to be a translation that's shifting x, y to x minus 2, y plus 3. What's going to happen to the point 7, 2 onto which point in the long run? So now notice we're going to take the 7. We're going to subtract 2 from it. 7 minus 2 is 5. We're going to start at positive 2. We're going to add 3. 2 plus 3 is 5. So the work I would hope to see is right up here. It's the first number of the point with whatever the direction says, so 7 minus 2. The second number of the point with whatever the directions tell me, so 2 plus 3 is 5. It gives me the point 5, 5. Question 2 says, what is the image of the point 3, negative 4 under the translation of negative 2, 0? And again, my original point, my rule. This tells me I want to start at 3 and subtract 2 from it or add negative 2. So 3 plus negative 2 or 3 minus 2 is 1. Negative 4 plus 0, which would be negative 4, and there's my answer. We'll skip 3 for a second. We'll go to number 4. Notice that we have the prime notation on this one. The original shape is this. So this is my pre-image. This is my image. You always end up at the prime notation or the one with the most. And all that happens here is this whole thing slid. They all slid the same distance in the same direction. That's an example of a translation. Choice 1. So question 3 and 5 are kind of asking the same thing. 5 says a translation moves A to A prime. And I say, what would be the image of X, Y under the translation, which is basically saying, what's the movement? So I really want to know, how did I get from A to A prime? And I really want you to break this up into 2 components. Look at the X value. It starts at 4 and it moves to 0. Think of a number line. How do you go from positive 4 to 0 on a number line? We have to subtract 4. Because that was my first number, those are the X values. So really that would be X minus 4 right here. My second number went from negative 2 to positive 2. Now this is a little tougher. Think of a number line. If you start at negative 2 on the number line and you want to go up to positive 2, you have to go from negative 2 to 0. And then from 0 to positive 2, you're really moving 4 total points. You're adding 4. And a quick check, negative 2 plus 4 is 2. Now that's the y component, so that gives me the y plus 4. So really the rule to get me from A to A prime is x minus 4, y plus 4. And that would work for any point. So going up to number 3, we're going from A to A prime again. So we want to find or establish our rule first. How do I go from 1 to negative 1? Well, I subtracted 2 to go from 1 to negative 1. How did I go from 2 to 3? Well, I added 1 to go from 2 to 3. So my x values went x minus 2. My y values went y plus 1. So the rule is really x minus 2, y plus 1. This question's a little weird because they use the word here instead of the number. They want to know if we started at the origin, where would we end up? Well, the origin really has the coordinate 0, 0. So plug a 0 in here and a 0 in there. You get 0 minus 2 is negative 2. And 0 plus 1 is 1. You get the point negative 2, 1 as your answer. Choice D. Not that I know of. Check with Mom, you'd have to know. I don't know. Question 6 is really doing the same idea. Now, I left the picture off here for you. You can fill this in, try it yourself. But what we're going to do is we're going to start with the triangle ABC. 3, 4, 1, 7, 3, 7. And then what we're going to do is do the image after reflection in the y-axis. So quick review. You know that when you reflect across the y-axis, you negate the x value. The x value is the first one. So 3, 4 turns into negative 3, 4. 1, 7 turns into negative 1, 7. and 3, 7 turns into negative 3, 7. I would say graph all these up here, and you'll notice that it flipped across the y-axis. This original triangle shows up over here. The only thing I ask, make sure you definitely label it as A prime, B prime, C prime. Part C, graph and state the coordinates of A double prime, B double prime, C double prime. The image of A prime, B prime, C prime. This right here tells me to use the one I just got, so that's why I like having these written down here. And I'm going to do a reflection across the line y equals x. Another review, remember, reflecting across the line y equals x tells me to take the 2 points and just switch them. So if I started at negative 3, 4 for A prime, A double prime will just be 4, negative 3. Negative 1, 7 turns into 7, negative 1. Negative 3, 7 turns into 7, negative 3. And that's how I got my B prime and C prime. And you want to graph those. It would come up here from quadrant 2. I believe it comes down here into quadrant 4. It might be right up against there. Pretty close. And then finally for part D, I want to find A triple prime, B triple prime, C triple prime, the image of the double prime. So I'm taking my answer from part C. I'm not using B. I'm not going back to A this time. It tells me right here the image of A double prime, B double prime, C double prime. So I want to use these. And I want to do a translation of x plus 5, y minus 1. Well, now if you already have it drawn here, that just tells you to move right 5, down 1. So you could take all 3 corners of your triangle, go right 5, down 1, right 5, down 1, right 5, down 1. It'll give you the answer. But it does want you to state the coordinates of it. So you'd have to write these down anyways. So I think it's easier to start with this. I'm going to take all my first numbers, and I'm just going to add 5. It says x plus 5. So 4 plus 5 is 9. 7 plus 5 is 12. 7 plus 5 again is 12. That's where I got the 9, 12, 12. Looking at the y values, it's y minus 1. It just tells me subtract 1. Well, negative 3 minus 1, just be careful here. It's really going to be negative 4. Negative 1 minus 1 is negative 2. And negative 3 minus 1 is negative 4 again. Graph those, see how you do. So once these are on your graph paper, you should have your final answer. Make sure you label them correctly. And then I want you to try page 26 to 28. Don't do all of them unless you want to. Just try 8, 9, 11, 12, 14, 16, 18, and 22. And then definitely make sure you let me know if you have any problems. I hope this works. First new lesson this way. Keep me up to date. Let me know if you're struggling with anything. If you have any questions, use the answer key online, and this can help you with all that stuff. All right. See you guys later.